Sets are very similar to lists in Python. However, there are a few key distinctions that can help you determine when to use one over the other. To create a set, use curly brackets and separate items via comma. The first key distinction is that sets contain no duplicate items. For example, if I tried to add another 1 to the set and then print the set, only one 1 will show on the output, because duplicates are not allowed. The second distinction is that sets have no order, unlike lists. As you can see here, the order of items I inputted is not the same as the order outputted. This is because sets use hash maps to directly access items, whereas lists are ordered. This makes sets much faster at membership testing, which is seeing if an item is contained in a set. It also makes comparison between two sets a lot faster than comparing two lists. For example, I create a script that finds the average time it takes to find a single element out of 10 million items in a list or set. As you can see here, the set performed about 16% faster on average than the list. The main reason for this is that lists check each item individually. For example, considering this list, if we were to search for 7, I would have to check items 1 through 6 before I can verify 7's existence. This means in any given list of length n, the worst case scenario is that you have to check n number of items before verifying that an item exists. This means that lists have a time complexity of n for finding a single item. Sets, on the other hand, can directly search for elements. They do this through the hash function. A hash function takes any input and transforms it into a 64-bit integer output. The key to this function is that any input always has the same output, though it is seemingly random. This output is then translated into a memory address, which can be used by Python to directly search if the element exists or not. This means sets have a time complexity of 1, as the time it takes to find an item is relatively independent from the size of the set. This makes them significantly faster than lists, especially for large sets. Due to this, sets are much faster at comparing two different data sets. Let's consider set A and set B, where set A is 1, 2, 3, 4, 5, and set B is 4, 5, 6, 7, 8. The intersection method returns a set of common items from both set A and set B. So in this example here, both 4 and 5 are common to set A and B. You think of this as a logical operation of an item belonging to both A and B. This method is also commutative, so A intersects B is the same as B intersects A. One use case for this is data analytics and marketing. For example, let's consider set A as people with good SAT scores and set B with people who are a junior or senior in high school. If you're a college, you would want to find the intersection and target these people for your marketing campaign. Let's now look at the union method. This method returns the joining of both sets A and B. You can think of this as an OR statement, where if it's in either A or if it's in B, it will be in the return set. This means that the property is commutative, where A union B is the same as B union A. If you look at this example here, all numbers 1 through 8 will be represented in the joined set. However, 4 and 5 will not be duplicated because sets don't have duplicates. The difference method returns a set of all elements that are unique to the original set. You can think of this as A and not B. So for example here, A is 1 through 5 and B is 4 through 8. Only 1, 2, and 3 are unique to A. Therefore, A difference B would be 1, 2, 3. However, this method is not commutative, as B difference A would be 6, 7, 8, as 6, 7, 8 are the only elements in B which are not in A. The symmetric difference method returns a set of all elements that are unique to either A or B. You can think of this as an exclusive OR. For example here, all elements unique to A are 1, 2, and 3, and all elements unique to B are 6, 7, 8. Therefore, A symmetric difference B would be 1, 2, 3, 6, 7, 8. And this is also commutative. It's essentially elements that are in A or B, but not in A and B, so excludes 4 and 5. The last thing to cover is subsets and supersets, which is essentially if one set contains another set. You can think of this as if B is in A. For example, here you have all elements in B are also in A, so therefore B is a subset of A. You could also inversely say that A is a superset of B because A contains all elements that B has. Here are what all four methods look like in Python. Additionally, if you wish to automatically update a set rather than return a value, you can use the keyword update after the method name. For example, if I use a.intersection_update b, it will update the set A to be the intersection of A and B. So now if I print A, it is transformed into the intersection of A and B. Now I will cover the remaining methods. The first method is add, which adds an item to the set. The next method is pop, which removes an arbitrary item from the set. As you can see here, the first item of the set was removed, but this isn't always the case, as sets are unordered. To remove a specific item from the set, you can use the remove method. Here, I'll specify to remove the item 3, and as you can see, the set no longer has 3. To completely clear a set, you can use the clear method, which deletes all items in the set. Additionally, the is-disjoint method can be used to determine if two sets are not intersecting each other. For example, both set A and B share common elements, therefore they are intersecting each other, so the is-disjoint method will return false, as they are not mutually exclusive sets. Finally, you can use the copy method to create a duplicate of the set as an entirely separate object. One last bonus tip is that if you have a data format already in a list, and you want to remove any duplicates, you can wrap the list as a set and then return it as a list. This will delete any duplicates, and as you can see, it can be returned to a list format. In conclusion, you should use sets over lists when you're comparing or contrasting two different collections or when searching through a collection. This is because sets both have the better operations and are more efficient at accomplishing these tasks.